In this section, we're going to talk about linear equations. First, we're going to talk about linear equations in one variable. So a linear equation in one variable is an equation that can be written in this form, ax plus b equals 0, where a and b are numbers. Usually numbers or letters. So here are a few examples. Notice that in this example, 3x plus 4 equals 5x minus 6, that we have only the x as a variable, and that the exponent on x is 1. That tells us that this is a linear equation. Here's another example of a linear equation, 4 minus 2y equals 8 plus 3y. This is a linear equation in the variable y. And here's another one. This time the coefficients are the constants or fractions. And in this last equation we have decimals as coefficients. So what does it mean to find a solution to an equation? Well, as you know, means what can we substitute in for the variable to make the equation true? So we're going to solve these equations. This should be review. So you know we need to put these two x coordinates together. So let's start there. If you said subtract 5x from both sides, then you're right. So that's where we're going to start. We're just going to subtract the 5x from both sides, and that's going to put them on the same side of the equal sign. And so here we have 3x minus 5x, which is a negative 2x, plus 4 equals negative 6. Now we want to move over the positive 4 over to the right-hand side, so we're going to subtract 4 from both sides. And so we get negative 2x equals negative 10. And of course, now to get our x by itself, we're going to have to divide by negative 2. So let's divide both sides by a negative 2. So x equals positive 5. And that's the solution. As you know, we can check the solution by substituting in for x, so I'll let you do that. In this example, we're going to move the 3y over by subtracting 3y from both sides. That'll put our y's together on the left. So I get 4 minus 5y equals 8. And now we want to subtract 4 from both sides. So that gives us a negative 5y equals 4. And then we're going to divide both sides by negative 5. And that will isolate our y. So we get that y equals negative 4/5. Now here we have fractions. So we're going to get these two y's on the same side of the equal sign, but because we have fractions, we're going to use our calculator to help us with the fractions. So let's start first with subtracting this 1/4 y from both sides. Now, as you remember from your fraction work, when we subtract fractions, we would need a common denominator. So we're going to postpone that for a bit. And I'm just going to write 1/3 minus 1/4 times y plus 4 equals 3. So we're just putting together those coefficients, kind of keeping track of them. And then we will use our calculator. Okay, so now let's subtract the 4, get it over to the other side with the 3. And so we have over here negative 1. And then on the left we have still this 1/3 minus 1/4 that we have to subtract times y equals negative 1. So let's divide both sides by this 1/3 minus 1/4. And now we're going to use our calculator so that we don't have to find common denominators. So here's your calculator, your graphing calculator. And we're going to just input in the fraction, making use of the parentheses. I can see that I forgot to put a negative 1 here, so our answer, we'll have to keep that in track. So here we're going to input 1 divided by 3, which gives us our 1/3. 1 divided by 3, subtract 1 divided by 4. Parentheses, and now, because I want my answer as a fraction, I'm going to use the math key and pick fraction, and then hit enter, and notice that my answer is 12, or actually, for us, it'll be negative 12 is the solution. Okay, in this next example, our coefficients of y are decimals, but we're going to still do the same thing. We're going to subtract 0.5y from both sides. That gives us a negative 0.2y plus 2 equals negative 3. And then we'll subtract 2 from both sides so that we can get the y by itself. And so negative 0.2y equals negative 5. And dividing by negative 0.2, we're going to get now that our y, well, we're going to use the calculator. Okay. So I'm clearing the screen, and then I'm going to put in so negative 5 divided by negative 0.2 is positive 25. Now, in these next examples, we want to solve for the given variable. So in the first example, I want to solve for W. Notice that we have a lot of other letters here. We have L's and we have P. But we still want to get the W by itself. So the first thing we're going to want to do is move over that 2L. And that 2L is not a like term with the P. So we're just going to write P minus 2L equals to W. And now we're going to divide by 2 so that we can get W by itself. And you may have recognized this formula as the perimeter formula for a rectangle. 2 lengths plus 2 widths equals a perimeter. So here's another formula we're going to be working with. This is a interest formula, simple interest. And so we're going to solve for R. And the first thing we're going to do is distribute the P. So we get A equals P plus PRT. Remember, we're trying to isolate R. So we're going to subtract the first P, that first term, from the A. Okay, I'm going to leave this. This is the R we want, and so this P needs to move over. So we're going to subtract it, put it on the other side with the A, so we get A minus P equals PRT. And now we're solving for R again, just a reminder. So we're going to have to get rid of the P and the T, which are multiplied with that R. So the way to move those over is to divide both sides by PT. So we'll divide by PT. And notice our P's and our T's cancel on the right, so we get R equals A minus P over PT. Okay, now we're going to deal with linear equations in 2 variables. So now we have variable x and y, and all the other coefficients are numbers. And when you have a linear equation written in this form with the x and y on the same side of the equal sign, we call that standard form. So here are a couple of examples of linear equations. 3x plus 2y equals 12, and 4x minus 3y equals 16. You notice that they're in the same standard form as the definition. Okay. So these are 2 linear equations in 2 variables in standard form. Now, because we have 2 variables, solutions to these equations are going to be order pairs. So you're going to have a value for x and a value for y. So they will be points or order pairs. Well, let's just do a little bit of practicing here with finding some solutions to linear equations. And let's take that first equation, which is 3x plus 2y equals 12. I'm going to make a table of values. And as you may recall, we get to choose the x value, and then we're going to solve for y. So let's start with x equals 0. And when x is 0, I'm going to substitute that in, and I get 3 times 0, which is 0, plus 2y equals 12. So 2 times 6 is 12. So we get y equals 6. So 0, 6 is one solution of the linear equation. All right, let's pick another solution. This time let's let x equal 2. So we substitute in 2 for x, and we get 3 times 2 plus 2y equals 12. So 6 plus 2y equals 12. And subtracting 6 so that we can solve for y, we get 2y equals 6, or y equals 3. So the y coordinate is 3. So the order pair 2, 3 is another solution. And one more, let's try x equals to 4. Substitute that in, we get 12 plus 2y equals 12. And subtracting here, we're going to get that 2y equals 0, so y is 0, because 2 times 0 is 0. So 4, 0 is another order pair. And as you may remember, there are infinite number of order pairs that are solutions to our linear equation. But let's plot these three that we found. So 0, 6, 2, 3, and 4, 0. Put little points on our coordinate and then draw the straight line. And there is our line. And of course, this point here is very important. This is the point where the line crosses the x-axis. So we call that the y-axis. So that's the y-intercept. And down here we get the x-intercept. So just to review here that the x-intercept and the y-intercepts are the points where the line crosses your two axes. So we're going to find the intercepts for the following equation. And the way that we find them is that we first set y equal to 0 to find the x-intercept. Just set y equal to 0, and we're going to solve for x. And that's going to give us the place where our line crosses the x-axis. So y is 0, 0.2x equals 1.6, because 4 times 0 is 0. So 0.2x is 1.6, and then divided by 0.2, we get that x. 1.6 divided by 0.2 is 8. So 8, 0 is the order pair that is our x-intercept. So we're going to put a dot there. Here's our point. Okay, and that's going to be our x-intercept. Now let's find the y-intercept. So for the y-intercept, we set x equal to 0. And then we solve for y. So that gives us 0.2 times 0 equals 4y plus 1.6. So over here on the left we have 0 equals 4y plus 1.6. Solving for y, we subtract the 4y to move it over to the left. So negative 4y equals 1.6, and divided by negative 4. And so we get that y equals negative 0.4. So we're going to put a dot between 1, about almost a little bit above halfway between 0 and negative 1 on the y-axis. And then we will graph our line passing through those 2 points. That gives us the graph of our linear equation. Okay, here's the definition of slope. Slope is defined as rise over run, or the change in y values over the change in x values in our line. So going back to that first example that we had, here's our graph, and we can pick 2 points. We're going to pick these 2 points and see what the change in y and the change in x is, and that'll give us our slope. So notice that y, so we're going to draw this right triangle here, and this leg is going to give us a change in y. So y goes down by 3, while x increases by 2. So making a ratio out of that, we get that the slope of this line is a -3/2. So now in this example, we've got 2 points, and we're going to find the slope by computing the change in y. So we're going to subtract the y values over the change in x, so we're going to subtract the x values. And so over here we get 1 minus minus 4, which is 5, and 5 minus 3 is 2, so 5 over 2 is the slope of our line. Okay, now here we have some graphs of some lines, and we want to find all of the lines that satisfy the given condition. In 51, it's that the slope is positive. So as you know, a positive slope means that the line is rising as you go from left to right. It's kind of like you could think of a car driving on this line, and the car's going uphill. So A has a positive slope, and so does D, as you can see, because our car would be going uphill if it was going up that line. Now to find where the slope is negative, we're looking for downhill lines. So E has a negative slope, and so does C. Now let's look at B. This is a special case. There is no change happening here with our y coordinates. This is a horizontal line, and horizontal lines have slope of 0. So we have no change in y, so therefore our slope is 0. For line F, which is a vertical line, now we have many changes in y but none in x. So that is a line with no slope, undefined. Okay, now we're at the slope-intercept form of a line, which is probably the form of the line that is most used. And that is y equals mx plus b. That may ring a bell for you, where m is the slope of the line and 0b is the y-intercept. So here's an equation, y equals 4x minus 3. And so you can see that this equation is already in slope-intercept form. So that tells us that our slope is the coefficient of x, which is 4. And our y-intercept, our b is -3, so our y-intercept is 0, -3. And we can use that fact to graph our line. So we're going to use 0, -3 as a starting point. And then for our slope, since our slope is 4, we're going to rewrite that as a ratio, which is 4 divided by 1, which tells us that we're going to go up 4 and write 1 from our starting point. And that gives us another point on our graph. We can repeat the process, up 4 and write 1. And now we're going to connect those three in a line, and there's our equation of our line. Okay, word problem. A health club charges a yearly membership fee of $95. Members must pay $2.50 per hour to use its facilities. How many hours did Jillian use the club last year? Her bill was $515. So let's model this with a linear equation. Okay, you can see that we have two things happening here. We have a cost and we have the hours that Jillian uses the club. And the hours determine the cost that she pays. So the hours are our X and the cost is our Y. And notice that she has to pay $2.50 per hour, so that's our rate. And so that will be our slope. And the yearly membership fee of $95 she has to pay regardless. So that is our y-intercept. So here's our equation. Y equals 250x plus 95. So to find the number of hours that Jillian uses the club, we're going to say y equal to 15 and solve for x. And so we're going to subtract 95. And that gives us 420 equals 2.5x. And now we're going to divide by 2.5. That's going to give us the number of hours that Jillian worked out in the year. And so using our calculator, 420 divided by 2.5 is 168 hours. Don't forget to put your units when you're answering these questions. Okay, very good.